Hi students. Before this video we were talking about the atmosphere. Now we're going to get into air pollution. Air pollutants are just gases or particles that are in the air that can affect either the climate or human or living things in a negative way. Air pollution can be caused by natural occurrences. Um, Typically we look at industrialized nations for the highest level of outdoor air pollution. And that's because of our production of energy and our use of technology like cars. Natural processes, though, can occur like forest fires. They can pollute the air as well. As we've seen in California, the forest fires can cause a lot of damage to people's lungs and also damage to surrounding plants as well. Volcanoes can also cause natural occurrences of air pollution where it releases a bunch of particulate matter and sulfur dioxide into the stratosphere. We'll talk more specifically about particulate matter in a little bit. But sulfur dioxide is a component in acid rain. It combines with water to make sulfuric acid, and that can cause the pH of the water in the atmosphere to go down, become acidic. Short-term effects, it can ground planes, it can damage car engines. We saw this in, I believe, Iceland in 2013, I believe, where there was a volcano that erupted and caused planes to be grounded. And it can cause respiratory issues. Long-term effects, it can actually cool the atmosphere or cool the earth because it protects this, blocks sunlight. And it produces sulfur dioxide, which again can block the sunlight and also cause acid rain. Finally, wind that's sweeping over arid terrain like deserts can blow dust into the atmosphere. And this is a bit, where we get into more of the human causes because we can also create more arid land that then blows dust into the atmosphere. How do we do that? Well, going back to sustainable agriculture, we have to be careful about our grazing practices and the way that we harvest vegetation and how we till our land. So we definitely create outdoor air pollution as well. There are two ways that we describe pollutants. One is called primary pollutants, where a pollutant is directly released into the atmosphere from a particular source. Example is like ash. It erupts and it goes in the atmosphere, and there it is. But sometimes primary pollutants can also react with each other or with some naturally occurring chemicals like oxygen in the air and nitrogen in the air, and they can cause then secondary pollutants. Things like ozone. They can form from pollutants in a combination of gases in smog, and so ozone is a secondary pollutant. The other aspect we have to consider, not just what type of pollutant, but how long do some of these pollutants stay in the atmosphere? We don't worry as much about really short-lived pollutants unless they're really toxic. We have to be very careful about like mercury or something in the atmosphere. But we really specifically focus on things that stay in the atmosphere for a very long time. Some of these even stay for centuries. The Clean Air Act is one way that we've addressed pollution. And in 1970, really that's the year that we sort of focus on, we set standards for air quality. And basically we said we would monitor the emissions and we would set standards and make sure that we try to enact laws in our state governments to monitor emissions. So the agencies that we have, like the EPA, monitor particular pollutants. The first one is carbon monoxide. Why do we monitor carbon monoxide? Well, it can impact your brain. It can impact your whole body because it can block the attachment of oxygen to your hemoglobin in your red blood cells. And so that can actually shut down your brain before you even know it because it's colorless and it's odorless. Where do we get a lot of carbon monoxide from? Vehicles and engines. Nitrogen oxides are also a big problem. This is a family of compounds that include nitric oxide and nitrogen dioxide, so NO and NO2. And it's produced when natural nitrogen gas, N2, and oxygen combine during the combustion of engines. So when we're burning, fuel. This is a contributor to smog. So it's a primary pollutant that can cause a secondary pollutant, smog. And it can also cause a secondary pollutant, air acid deposition or air acid rain. That's another way of saying it. And can deplete the ozone layer as well. The third chemical is volatile organic compounds, or VOCs for short. These are carbon-based chemicals that are produced when vehicles are combusting fuel or through solvents like paint thinners. Examples are like methane and propane. These are very small, very light molecules that can get out in the atmosphere when we're like pumping gas. When you smell gasoline, what you're really smelling are the VOCs when you're at the pump. Okay, that's stuff that's evaporating and getting up into your nose. That can actually cause a lot of respiratory problems, and it's also one of the primary ingredients in smog, the secondary pollutant. Particulate matter, or PM for short. These are just tiny solid or liquid particles that can be suspended in air. And we classify them in two different ways. PM10, which is a little bit larger, and PM2.5, which is, obviously smaller. Lead is yet another chemical that we look at. We have to be careful because it can accumulate in our bodies and in our nervous system specifically and cause issues there. And we've done great work with, helping to protect people from lead poisoning because we've reduced the amount of leaded gasoline. We used to put lead in gasoline. And also metal smelting, which is basically, breaking down, melting rock to make metal. And as I said, we're doing a great job. Over the course of the last 40 years, or 50 years rather, we've been monitoring these 6 pollutants and we've reduced these pollutants, even though the number of Americans over the last 50 years has gone up and the amount of energy we've used per person has gone up. That's a great testament to the EPA and to our government's efforts. How do we do this? Well, one way is to use something called scrubbers. This is an example of a scrubber where we have mist that is capturing pollutants in this dirty air. And it's as a result of the mist collecting with the air pollutants in the air, it sinks them down into a smaller settling tank that is then removed and sent to a hazardous waste landfill. Another is catalytic converters. This is something we have in all cars, and it helps to take the carbon monoxide and nitrogen oxides and hydrocarbons and convert them into nitrogen gas, carbon dioxide, and water vapor. Can you tell me why that's a good thing? What are some of the issues associated with carbon monoxide? What are some of the issues associated with nitrogen oxides? What are some of the issues associated with hydrocarbons like VOCs? So you should be able to answer those questions. Catalytic converters are awesome. So as we saw, there are 6 what we call criteria pollutants that the EPA looks at. And we've created some air quality standards. Others to consider are nitrogen dioxide, NO2, and tropospheric ozone, or ground level ozone. Ozone, again, as we said before in our example of secondary pollutants, it is made from 2 or more other things. So it's created from nitrogen oxides and VOCs combining with sunlight. Okay? This is the process we'll talk about later called photochemical smog. It can cause injury in living tissue and cause respiratory problems. So we have to be really careful about ozone. Um, Again, we're doing a pretty good job overall. Concentrations of these particular pollutants has gone down, as you can tell. We monitor very specific pollutants called toxic air pollutants that are highly, highly poisonous and toxic to us at very small amounts, like mercury, for example. Um, and rural areas can also have problems too with pesticides from farms, industrial pollutants that come over from cities, and animal waste and what we do with that. It can produce chemicals like VOCs for methane, nitrogen sulfide, ammonia. All of those are particular problems for rural areas. Industrial countries or industrialized countries um, can start to open up factories and produce a lot of energy for their countries. But if the laws don't sort of match the growth, then you have a lot of air pollution being produced at a very fast rate. We get a lot of air pollution, for example, in China and in Delhi. These are two pictures here of cities that are dealing with air pollution all the time, wearing masks, canceling flights, having stay indoor days. So we talked a bit about smog. Smog is a secondary air pollutant. Smog can occur in two ways: through industrialization or industrial smog, and the second way is through photochemical smog. Industrial smog is produced when you have coal or oil being burned, and that produces sulfur dioxide and some particulate matter in the atmosphere. And sulfur dioxide and soot can cause that smog. Another thing that can happen is sulfur dioxide connects with water and oxygen and produces sulfuric acid. Sulfuric acid is acid rain. It can cause acid rain. This is an example of a couple of industrialized smogs that occurred in Donora, Pennsylvania and London, killing dozens, or even in this case of London, thousands of people. Photochemical smog is probably the smog that you've heard about the most. If you look at, LA and Mexico City, we're really talking about photochemical smog. These are places that have a lot of sun, and sun can be great, can be fun, but can also accelerate the reaction between primary pollutants to make secondary pollutants like ozone. This is the process of making photochemical smog. It's important that we understand this process. It starts with the burning of gasoline and diesel in cars. What that does is it produces VOCs and nitric oxides, nitrogen dioxide. Now, we've reduced the number of or the amount of these three things, NO2, NO, and VOCs, with anyone? Catalytic converters, if you go back to catalytic converters. But not all. We're doing our best, right? This is why we have to inspect our cars, make sure that it's working properly. But over time, just a little bit from each car can produce, in really high traffic times, a lot of these, and that can combine with oxygen in the air and nitric oxide and react with the sun to make ozone, O3. Nitrogen dioxide can get in there and really cause it to make it look like a brown or a reddish color as well. What can we do? We can restrict the emissions from our power plants and oil refineries. We can have regular vehicle inspections, and we can improve on the technology in our cars, like make catalytic converters even more efficient. But we've done our best. We've actually decreased the amount of smog levels in LA over the last 40 years, as you can see.